welcome everybody. Good morning. It's a very early morning, at least for me. Welcome to my talk, GraphQL versus traditional REST API. Okay, first of all, let me introduce myself. My name is Vladimir Dejanovic. If you want to contact me, this is like the Twitter, mail, blog. I'm part of IT scene since 2006. In other words, I'm getting paid for the work I do since 2006. Also, I'm a founder and leader of Amsterdam Java User Group, and I'm also giving talks at conferences, but enough about me. So, what this talk is going to be about? First, I will spend some time talking about the REST, basically, and what we think when we say traditional REST APIs. After which I will spend some time on the GraphQL, what the GraphQL is, and most of the talk will be basically comparison between the traditional REST APIs and the GraphQL. At the end, there will be some time for questions, so if you have any questions, please wait until the end, or you can also contact me online, because after this talk, I have to run to the airport. Morning. Okay, so what is REST? This might sound as a very silly question, right? Because like, who here develop REST APIs? Yeah, basically everybody, right? So why should I ask a question like this? So obvious to everybody, right? Well, the reason for that is that if we would really go for developers and ask this question, we would get a lot of different answers, and unfortunately, a lot of them would be wrong. And the reason for that is that the REST has a very formal definition defined in 2000 by Roy Fielding, and if you want to read whole doctor dissertation, this is the URL. It's very good, but we don't have enough time for that. So let's look at basic REST in a nutshell. Basically, it's client-server architecture. There's a client and a server. Separation of concerns. Statelessness. Server has no clue about the client. Everything basically that the server needs to respond to the client has to be in client's request. Cacheability. Server has a possibility basically to say if some response should be cached and for how long. Layered system. Client that have no clue if it's talking directly to the server or is going through multiple layers before it's hitting the server. Code on demand is optional. In a nutshell, it means that the server can send a piece of code to the client which the client can execute. And last but not the least is uniform interface, which is like the biggest part of the REST. And again, in simple terms, it means that different parts of system can evolve independently from one another. But again, like doctor dissertation and everything is nice, but in real life, we don't care about them, right, that much. Especially our clients and our bosses. They care about the software which actually works. So what is REST in real life? Well, usually it means there is some data source, right? Somewhere where we actually get all the data. Maybe, for example, database. Then we have basically our application, our API, which reads that data source and exposes it to the front end, basically to the consumers. This is sometimes done field by field, like explicitly, like without any transformation or anything, just going to the data source, getting the data, and shipping it to the front end. And this is so-called crude REST APIs, and 90% of the APIs, and maybe even more, is basically just this. So let's look now at some simple example of the blog. So let's assume we have a blog, and we have a table with an author. There's an ID and a name, of course. Then we have a posts, because that's a blog, right? So we'll have ID, we'll have a title of a blog, body of a blog, and of course ID of the author who created it. And this is going to be a little bit more advanced blog. So we're also going to have options of comments, like comments would have ID, text, post ID, and author ID. So let's now look at the code. I will be using this URL throughout the talk. I'll just going basically through the different tags as we go along. Okay, so yeah. So if we look at the code, basically there should be no strange thing for everybody here. Basically, we have some. Yeah, I'll make it bigger as soon as I open the code. So basically we have an author, right? Big enough? So basically we have an author, and author is very simple, exactly same like a database, you know? Like a table, like we have an ID and a name. Basically here I'm using data, so I'm using Lombok to actually generate all the getters and setters for me, so because I'm a lazy person. And because I'm using MongoDB, I'm saying, okay, this is the document. Then we also have an author repository. And again, because this is MongoDB with a Spring Boot, it's very simple. I just say author repository, extends Mongo repository, basically that's it. If we look at the posts, again, the same thing, exactly the same, like a table, like nothing fancy here. We have ID, author ID, title body, same thing for post repository. Again, we have just post repository, which extends Mongo repository. So let's look at where's the thing? Demo control, yeah. So let's look basically at the controller, which actually does all the work. So again, because I'm using Spring, I just sent it with the REST controller. We have an endpoint basically with these authors, where I get all the authors. I can ask for author by ID. I can ask for all posts, or I can filter them on author ID. Also, I can ask for all comments, or I can filter by post ID. So nothing fancy here. Okay, so this is up and running. So if, for example, I ask for all posts, I get all the posts, right? So imagine that you have a website, so somebody basically hit your web page, you're going to hit this, basically this URL, get all the posts and show to him. And then if that person wants to see a specific post, then maybe you want to show the author ID. So then in that case, you of course are going to ask, okay, give me the author ID, basically information about the author, or also you might say, okay, give me all the comments for that particular post. So again, it's very simple, but I think that we can all agree that this could be good enough to actually create a real website. So will it be the best approach? That's a different thing. Okay, so let's actually go now to GraphQL. So what is GraphQL? And the first time I've heard about GraphQL, I also had this question, and I did what everybody does, just go to the Google, right? And when I went to the Google, I went to the official website, and this is what I found. GraphQL is a query language for APIs. And I was like, okay, what does that mean? So I did, of course, the sensible thing. I continued to read more, and then I came to a very simple conclusion. And that is that GraphQL is a specification, nothing more, nothing less. And it is important to remember this because we, as developers, we don't work with specifications per se. We are working with implementations of specification. And again, in case of GraphQL, there are implementations in JavaScript, Java, Go, PHP, and every day there's basically some new implementation of a GraphQL. But again, why we need to remember that we're working with implementations and not with specifications is because whoever is basically creating the implementation doesn't have to cover whole specification. Maybe they covered everything, maybe they added some of their own specific flavors, or so keep in mind which implementation you are using, and basically what are its limitations, and basically where it's at the moment. I'm going to use the GraphQL Java implementation throughout my examples. But again, talking is boring, so let's look at the code, right? Again, the same URL, different tag. So, okay, let this start up. While it's starting up, let me show the code. So, first things first that I want to show you is basically the database. Basically, the POJOs are exactly the same. So nothing changed here. So POJO is exactly the same. Repository is exactly the same. So actually, where difference are compared to the come on, where is it? I managed to take the right one. I took the GraphQL, right? Yeah, but then where's my file? Because here there should be a file. Ah, here it is, of course, late. Why is it being late? Okay. So basically with the GraphQL, the important part is this schema. And here basically you define all the important stuff. So in my case, here I'm defining that I have a type of name author, and you can see that I have ID, field of ID, type ID, and this one sign basically means that this field is mandatory. So it has to be there. It can't be null. Then I have a name, and I have a string. So if we take a look at the author, and basically my POJO, basically my table, you will see that they are one-to-one. And also I'm using the same name, which is not coincidence. Basically, with this way, the Java code will know how to basically map my Java objects to the GraphQL schema. Then we have basically the post. Again, the same thing, exactly the same like a Pojo, no difference. We have an ID, we have a title, we have a body, we have an author ID, exactly the same. Then there are comments, basically again, exactly the same like a Pojo. So far, everything is the same, right? There are no differences. And then here, basically we come to the heart of the GraphQL, and that's basically the schema. Here, basically we say to the GraphQL, okay, how outside world can actually interact with us. And we say we have a query, and it's going to be of a type query. Query is also typed like everything else, and basically it has one field here, all posts, which return array of posts. So this is how you define in GraphQL schema array of posts. So let's look at basically at the Java code which actually implements this schema. So first thing, no, not this one. I forgot forever. Okay, so first thing first, I want to show you this. So this is basically my boot application, right? And here I'm defining the servlet in a standard, basically standard Spring way, and I'm saying, okay, on this endpoint /GraphQL, register this servlet. So let's look at this servlet. This is basically my GraphQL servlet, and it extends simple GraphQL servlet, nothing fancy here, so a lot of things is already done for me. So that's why good thing with this implementation in Java, like a lot of things are already done for you. Only thing that I need to do is, of course, create one constructor, and basically here I have one method which provides me with the GraphQL schema. So I'm saying schema parser, new parser, and here I provide my GraphQL schema file. Then I have a part with resolvers, and then I build it and make it executable. So if we look now what actually this resolver is, so you can see that's called query, and that is exactly the same like this type here, and that is not coincidence. That is on purpose. That's how basically the Java code knows how to map basically GraphQL schema and the Java code. Again, if you go here, you will see that I'm implementing GraphQL root resolver. So I have to make one comment here. At the moment, I'm using very old GraphQL Java implementation. It's 3 point something, and in the new versions they changed this. So now you don't write GraphQL root resolver, you write GraphQL query resolver. So that's the only difference at the moment. And again, here I have a method called allPosts. And again, if we go back to the schema, you will see that it's exactly the same like here, allPosts. Here is returning the array of posts. And here I'm getting back the list of posts. And this is not coincidence. Like, this naming is very important because that is how Java code knows how to basically map all the Java codes and methods and everything to the GraphQL schema and actually how to wire them up. So let's look at the demo. Okay, this one is up and running. Another nice thing with the GraphQL is that by default you get very easily this GraphQL thingy, which is actually like a playground that you can play and basically see your code in action. So my application is up and running, so I can type here query, and you can see it's auto-completing. So I can say, okay, all posts, right? And then I can say ID, title, body, right? And author ID. And I can run it, and voila, here I get the data. But this is exactly the same like I had in the REST API, so what's the big deal, right? Well, something that you get out of the box with the GraphQL, which is nice, is that, for example, you can remove this, and you get only the fields that you ask. So you have filtering out of the box. Another nice thing is that also here, you have dynamically already created the documentation. So you can see, okay, I have a query. For query, it returns, I have a method allPost, which will return the post. Post consists of these things. So it's very easy to basically, if somebody else gives you the GraphQL endpoint, understand what you can get from it. Okay, so let's now just go quickly and compare the GraphQL with definition of the REST API. Client server architecture, where I showed you the client and the server, so yes. Statelessness, well, I used the almost standard Java servlet, so yes. Basically, it's up to me to make sure it's statelessness. Cacheability, again, the same thing. Layered system, again, it's a true thing. Code on demand, well, it was optional from the start, so yes. And the uniform interface, well, I showed you the GraphQL schema, so yes, big yes. So basically, the GraphQL is a REST API. It is very advanced REST API, but REST API nonetheless. So if we talk about REST, we all know that the schema is optional, right? You can go first basically with the code and then generate the schema, or you can generate have the schema and then generate the code from it, or you can completely forget the schema altogether. Everything will work. It's completely optional. My advice to you is always have schema, because it will help you very much in real life, you know. But again, if you don't have it, everything will continue to work. This is a big difference compared to the GraphQL. With GraphQL, schema is mandatory. So you can either do what I did, have a schema, and then basically generate the code, which actually maps to the schema, or you can do it either way around. Have a code, add certain annotations, and basically generate the schema. But either way, schema is mandatory. It has to exist. And there is a simple reason for that. Because when the client actually talks to the GraphQL API, it can ask basically for its schema definition. And basically the GraphQL will actually provide, okay, this is the schema, this is how requests should look like, and this is how responses will look like. Sorry. Then client can actually save that schema somewhere and make sure that every request which is sent to the server is the correct one. Because again, like, what's the point of sending a request which you know in front that is not going to work, right? What's the point? Again, if you're a naughty person and you basically force to send invalid requests to the server, what the GraphQL is going to do is basically going to look at your query, look at the schema, see if they're matched, basically if the query is valid or not, and only going to do the processing if the query is valid. If the query is not valid, it's going to send the error right away. So that's one of the reasons why the schema is mandatory. If we talk about advanced REST APIs, we have to talk about H2S. And in a nutshell, H2S is basically API which is like a website, explorable and basically self-explanatory. Because when you go to the website, you don't know about all the links, about all the connections, about all the stuff inside it, but you as a human person can just basically go through it and understand where to go. Well, H2S is basically the same thing for the REST APIs, and all the very advanced REST APIs behave in this way. And this is what I thought basically when I said that the GraphQL is advanced REST API. But again, let's look at the code. So we go number 2. Okay, I can put this up. Okay, where's the refresh? Is this up and running? No yet. Okay, so this is now. Okay, so if you go back to the schema, there is one small difference. And basically here in a type, I removed author ID and I added this field created by, and basically said, okay, it's of type author. So, okay, it's up and running now. So if we go here and basically just refresh the page so that my client gets the new schema, I understand that now it can ask more stuff. If I say here created by, I here now basically can get the information about the author. And this is the full object, so I can ask whatever I want to here. I can also ask here, okay, like, do you want ID? No. Everything which is there. Which is nice, right? But how it actually works? So if we go here, we open the post. Post is exactly the same. So I didn't change post. So the database layer is exactly the same. Okay, let's look at post repository, right? Also, it is exactly the same. So where there is a difference is if we basically go here, you will see that before I had one resolver, which was query resolver. Now I have another resolver, which is post resolver. Okay, so let's look what actually this resolver does. Well, post resolver implements GraphQL resolver, and you will see here that I added this type of post. So basically, whenever GraphQL needs to resolve something for the post, and those fields are not in the page itself, it's going to basically look, is there any resolver for the type of post? And this way I'm saying, okay, this is resolver for the type of post. And here you can see basically I have a method conveniently called created by. Exactly the same like one in schema, right? So exactly the same. And also it's taking post and it's returning back the author. So that is basically how GraphQL, again, Java implementations know how to map all my methods in Java classes and everything else to the GraphQL schema. So basically what we had was, at the start we had something like this, right? I had a client and basically I had a type post, author and comment, but there was no connection between them. So the client could get only information about the post. But then I added this line, right? I added connection between the post and the author and basically allowed to whoever actually asks any information about the post can also ask for appropriate information about the author. But why stop here? Like, why not go all over the way, right? So we can connect author and post, we can connect post and comment, then we can connect comment and post, and we can connect comment and author, right? So we get the full graph. Okay, so let's look at how that looks like now. Okay. Yeah. So if we open, where is the schema? So basically, if we just open the schema, yeah, I need to refresh, of course. Yes. Okay, it's refreshed. So basically now we have an author, right? And to author we added all the posts, which is an array of posts. To the post we also added comments, which is an array of list of comments, right? To the comments we added created by, and we added belongs to. And that's basically it from the schema. So what else did we change? So here we added two more resolvers. So now we have an auto resolver and the comment resolver. And if we open them, you will see that eventually this comes back to life. Changing code too often isn't always the good thing. Okay, forget, I'll not show it. Basically, it's more or less exactly the same like the previous one. So it again implements the GraphQL resolver of appropriate type, and all the fields which are missing are there. So now basically we can ask something like this, right? Okay, so I can ask for comments. Oh no, I need also to refresh this one. I can ask for comments. I can ask for created by. Yeah, let's put here text. Yes, created by name. Then we can ask for posts. And we can ask for title, and we can go on. So basically, we can create some crazy query like this one, and it all works. So if I go back now to original definition of the GraphQL, which says that GraphQL is a query language for APIs, I think that now you get it, right? What actually it means. Correct? So basic idea behind the GraphQL was that it should be used like something like this. You have basically a client on one side, and you have a lot of other systems on the other side. You have basically like other APIs, other applications, database, data source, whatever. And basically then you put the GraphQL in front of them and expose all the information which they have through the GraphQL basically query language, which is extremely powerful. And then basically the client can just go and choose what they basically want to do, which information they want to get, in which way, and how. So GraphQL has extremely powerful query language. I didn't show you everything that actually it can do. I just showed you one small part of it. There's also the conditional parts, which actually you can say, okay, in case of this data exists, show me this, or if some condition is met, do this. Also, you can actually change the names of in response. So here, basically, you can change this like ID, title, comments. You can actually change those values in response if you want. It is a very powerful thing. Also, one thing that you need to keep in mind is with the GraphQL, basically the client is given a lot of power at his fingertips. And basically, in the case of GraphQL, client call all the shots. It's not us anymore. Because and there's a big difference between traditional REST API and the GraphQL. Because in traditional REST, basically we say, okay, this is the endpoints, this is how the response will look like, this is the information that you will get, and that's the deal. We know where the user can go, which route they're going to follow for our application, what's going to happen. With GraphQL, we really don't know that. With GraphQL, we just say, okay, this is the types that we have, this is the connections between them, and basically this is what we can provide to you. But it's up to you to basically say, okay, what you want or what you don't want, and in which way and how. And you need to remember this. And one big reason for that is, if we look at my simple example, we have a big problem here. And the problem here is that we have cyclic dependency. So it means that basically if somebody by mistake or on purpose can very simply write the query like this. And you might say, okay, well, yeah, what's the problem? Well, this is the problem. Basically, can go on and on and on forever. So basically, my current implementation, luckily it's only for demos, somebody who actually wants can crash it very easily, because it can just ask for like crazy amount of data. So we need to be aware of that, and we need to think, okay, how do we protect ourselves from the abuse? And there are a few ways. The simplest but least effective way is the timeout. We just say, okay, timeout, too much time, go away. But the problem with this approach is, although that you to the client will say, okay, it's timeout, your machine is still going to use the CPU, is still going to use memory, it can still go down. So it's not really a good protection. The better protection would be basically to go with the maximum query depth. If you remember, I said that GraphQL basically takes the query and validates it according to the schema. So before it does any kind of work. So in that validation, you can also check, okay, what's the maximum depth of a query? If it's above certain limit, then it's just going to be too expensive and I will not do it. The problem with that approach is, again, it's more complex to actually implement, and it will not protect you against the attack of the width. So the better, but even more complex to implement is max query complexity, where for every part of a query you say, okay, this is the complexity of this query, basically this part. Then when you do the static analysis of the whole query, you sum all these values and say, okay, if it's above certain value, it is just too complex and I will not do it. The problem also with this approach is that maintaining it is going to be much more difficult. Because basically, like, when you write the code, you will know how much something is complex or not. But think about half year later, 1 year later, if somebody else comes and change something, will that person know how actually to also update this complexity matrix? So it's more tricky. The best approach, but most difficult, of course, to implement is just throttling, where for every query you just give a certain amount of time and CPU every few cycles. Again, depending on the implementation that you're going to use, some of these protections are already baked in, or maybe none of them. So that's why you need to be aware, okay, what is the implementation which I'm using, and basically what it gives me, and what I need to do myself. Can we wait for until then? Okay, thank you. So the GraphQL query language consists of the 3 big parts. The one part is query, and I showed you, and it's basically reading the data. What you need to remember about reading the data, it's done in parallel. So it's basically very fast. The other part is, of course, is mutation, because again, you have to change the data. If you just read the data, what's the point of it? When we're changing the data, it's basically sequential, so it's one by one. So let's look at that example quickly. Okay. So let's look at the code. And the difference in the code, again, it's not going to be much big, so to say. So in a schema, here I define mutation, and I say it's of type mutation. And again, here I just defined any mutation as any other type. I just say, okay, there is an author. And in this case, I'm here saying, okay, I'm going to send parameter of the name type, and the type is going to be string. And I'm going to return back the author. And also here I have remove author. This is good enough, yeah. Remove the author, and basically there's going to be ID and of type ID, and I'm going to return the author. Important thing to remember is that you can do this also in a query part. So if, for example, you want to do the queries and you actually want to filter something, or you want to actually like do the pagination, things like that, you can send parameters in exactly the same way like mutation. So from the GraphQL point of view, it doesn't really care. It's like mutation of a query. It's all exactly the same language. Also, you will see like I'm using here the, yeah, let's go back to that one. So if we go back to my GraphQL endpoint, you will see I added additional endpoint, which is mutation. And if we open that one, we will see that again, mutation implements, in this case, GraphQL root resolver. In newer versions of the GraphQL Java, it will implement the GraphQL mutation resolver. This name here, mutation, needs to be exactly the same like in schema. But it doesn't have to be mutation. You can put whatever you want to put there. But it is a good practice to actually use query and mutation, because then everybody who opens the GraphQL schema will know exactly what it does. So you can change the name if you want, but again, keeping to the standards is much better. Again, we have mutation, right? We have a method called addAuthor, which of course takes the parameter of type string name and returns the author, and the same thing for removing the author. So again, it's almost exactly the same like queries. There is no big difference or anything. So let's look at it now in an action. Okay. Okay. So let's mutation, add author, name, and let's put some name. Yes. And yeah, so here we have, and it works. And of course, we can also, I was supposed to first do this, but I also add these all authors. We get all authors. So basically, that's it about mutation. No, nothing fancy there, nothing groundbreaking. The third part of a GraphQL query language is subscription. And I will not go into demo it because I don't have time. Also, additional reason because in the version 3.0 it wasn't implemented, but now it is implemented. And idea behind the subscription is simple. It's similar to the query. You send the request basically to the server, and then you constantly get back informations. So that's the difference. With the query, you basically send request, you get response. With subscription, you send request, and then you constantly get the stream of information back. So there are some questions that we need to ask ourselves regarding the GraphQL. And the first and most important thing is, of course, okay, how do we deal with errors responses, right? Because with the REST, we know we get like 400s and all these kind of things, right? As a status code. Well, here's every time it's 200. So basically how you deal with that one here is, let's say that I send something like this, which is invalid request, right? So you will see the data is this case is null. Well, then here I basically had an errors. And this is basically how with the GraphQL deals with errors. So good thing about specification is that somebody already thought about it, so you can just use it. You don't have to like go into meetings and say, okay, let's use this status code for this, use the status code for this, let's format the messages in this way. It's already taken care of for you. There are some standards which are already there, but also there is a way that you can actually customize it and extend it according to your preferences. Other thing is basically performance and cache. Like I said, my current implementation is very error prone. It can be really killed very easily, especially if there's a bigger amount of data. So imagine if I had like 1 million records in a database, right? And somebody just say, okay, give me all posts and all the authors, and then just create the query to ask, my machine would die. So we need, in real life, we need performance, and we need to worry about performance, and we need cache. Well, GraphQL doesn't really care about it. From the GraphQL point of view, it doesn't care at all. It's up to you. So certain implementations basically already baked in some solutions for that. Some haven't done anything and just say, okay, it's up to you, do whatever you want to do. The good thing is that a lot of old tricks from the traditional REST APIs, we can also use, in this case, to solve the problems. When it comes to authentication and authorization, again, GraphQL is specification and it doesn't care. In a real practice, again, it's up to us to deal with it, and usually what we do is use the custom context. And again, in case of GraphQL Java, there are already hooks that you can just plug in and basically like with a very small amount and changes in code, say, okay, this endpoint is accessible only if user has this role. This is where basically I'm going to do authentication. So do all whatever you need to do. It's very easy to actually, with just small modifications of code, to do it. So let's now summarize a little bit. So, okay, bad title. GraphQL and the traditional REST APIs are very similar. Like you saw, the GraphQL is actually advanced REST API. So they're very similar, but there are, of course, some differences, right? They're not one-to-one. When we talk about tools and knowledge, well, the REST APIs are here for a very, very long time. They were with us even before Roy Fielding actually defined them in doctor dissertation. So the knowledge that people have, the amount of tools and everything that surrounds them is huge. With the GraphQL, that's not the case. GraphQL is publicly available since 2015, but it's getting much more and more implementations. The tools are getting more and more basically time and everything. So the gap is getting smaller and smaller. Again, like I said, a very good thing is that a lot of old tricks can basically, from the traditional REST APIs that we use for the caching, for authorization, for all other kinds of things that we can encounter, can be reused in a GraphQL. Some are basically one-to-one, some we just need to tweak a little bit, and it all works. We just need sometimes to think a little bit out of the box. GraphQL has extremely rich SDL, or schema definition language. Again, I didn't show you everything that is there. You can define new scalars. You can basically define interfaces like basically in Java. And then when you have some type, you can basically make sure that certain fields from the interface are present there. You can also create unions, which is something which I found personally very, very nice and very, very cozy, because I missed that opportunity basically in some other specifications for the REST API, like Open API, RAML, and things like that. Whenever you need to create really an union, it can become tricky. So GraphQL has extremely rich SDL, and I urge you to actually look into it more. Again, I didn't show you everything. Like I said, GraphQL has extremely powerful query language. It's not on the level of the SQL, so you can't really do the grouping and all these kind of things, but almost everything else is there. So again, I didn't show everything which is there. I just showed you a small part of it. I didn't show you how to do conditionals, how to actually check which type you basically get, and then do certain things depending on which type you got. So there are a lot of things there. Thank you. Okay. Any questions? There was a question, yeah. This one, right? Yes. Okay, so the question is basically, if I understand, can we create like a whitelist of the queries which are allowed, or? Well, in theory, it can be done, because again, there is a part when actually the GraphQL takes the query and validates according to the GraphQL schema. So in theory, you can do that, but again, then it's kind of, why would you use then the GraphQL? Then it's kind of counterproductive to the whole idea about the GraphQL. So I'm not sure how easy would it be to actually create the whitelist of the queries, but then again, leave the client with the functionality and basically the freedom that they expect from the GraphQL, because that's the difference with the, like I said, like in the REST API, basically we think, okay, this is the endpoint, this connection, things like that. With the GraphQL, it's the other way around. We just say, okay, this is what we have, but you decide what you get. So, at least in my point of view, I think it would be counterproductive, but yeah? Yeah. Yeah, but again, like I said, like I see your point. Basically, yeah, when we deploy and we know who's using us, we know the request, but then what tomorrow if happens, they want to actually change something. They want to add another query. Then you also need to change on your part, the whitelist and everything. So that's why I said it's counterintuitive, basically the idea of the GraphQL, because the idea is here is, I'm a backend developer, I will say, okay, like in the database, basically I have these tables, basically these are the foreign keys between them, and you basically, as a front-end person or like or mobile, whatever, you know, ask for a query which you want. And if you want to change something in your front end, I don't care. You know, for example, this thing that we have that I have now in my current job basically is like, okay, we create some stuff, and then tomorrow one team says, okay, I want this field, the other team want that field, the other field want that field, but then they don't want to get all the fields because it's a lot of data which goes over the wire. So, you know, that's then the limitation of the traditional REST, because then you have to think, okay, how I meet all the requirements, basically that everybody is happy and I'm not killing myself. You know, on the other side with the GraphQL is basically, okay, go play, you know. Again, protection from abuse is much more difficult, I agree. But again, like with few tweaks, it's not that impossible. Any other questions? Yeah? Yeah, basically that's what I said, like, if we go back, where's my thing here? So when I added mutation, daughter. So basically, yeah, so whatever. So this is the way that you actually send parameters. So you can send this way parameters, you can send in a query, in also like in mutation, in subscription. So in this case, you can also say just, okay, in my case, I don't have like, so I was query, ay, caramba. So if I say I'll pause, then I could say, for example, you know, page, I don't know, number 1 and size is 30. You know, so, but then of course, your method will need to be able to accept these parameters. And then again, you do whatever you want to do. So the GraphQL as per se doesn't really care about the pagination and all those kind of things. It's just say, okay, this is the types. Basically, I will just map them to certain pages basically in Java. All the fields which I actually can't find there, I will expect some resolver, which actually there will be a method with same signature, and then I will just call it. And then basically what the logic is going to be inside is completely up to you. So you can do pagination, filtering, whatever you want to do. It's just basically send parameters and basically then deal with it in the backend. Yeah?
Can a client connect and invoke multiple servers, so making use of different schemas and bind those together by using namespaces to provide a relation between several
If you mean, okay, so let me just see if you mean something like this, that you have one GraphQL and then basically a lot of behind? Well, yeah, so I think you understand, if I understand your question, basically you would think, okay, you have like some GraphQL server 1 and GraphQL server 2, and basically they're like in different data centers or something, and basically they have different information, and then somehow the client connect both of them, right?
Yes, so you use the same language to find multiple.
To be honest with you, I can't really like say for sure yes or no, but my gut feeling says that probably you will have to basically make 2 calls. And then basically in the front end actually do the merging or whatever. I'm not sure. Or you can just put one GraphQL in front of both of them. And basically, because again, that's a little bit tricky, because when you start doing with the GraphQL, and basically then the GraphQL schema file starts to grow. So it's then basically like either you split in multiple files, but then if you split in multiple files, then you basically lose connection between them. And if you keep it in one file, then it's going to be one big file. But it's basically, I think, just balancing up, you know, in case to case. So my gut feeling would be either create one GraphQL which actually talks to the both, or do in the front end basically the merging. So I'm not sure that there's like, maybe there is a very easy way, but if there is, I don't know at the moment. You also had another question, right? Yeah.
Well, just wondering, I think you showed a notation in guess. Can you observe the normal REST practice of doing it as a post? Or?
So in my case, everything is going with the post. So in my examples, everything was going with as a post, which is not always the best. So let me show here web developer. Yeah, so here, I'm not sure. Okay, so just give me a second. Let me delete this. So that's also one thing that first time when I saw it, especially with this one, I was like kind of surprised. And basically here, so okay, let's say name, right? So if I send this one, you see it's post. I'm not sure if you see it or it's big. It's big enough. I'm not sure if I can make this one bigger. It's everything here goes as post. So then my first impression was okay, like that's going to kill performance, right? If everything goes as a post, then its performance is a no-no. But basically the GraphQL know automatically that all the queries can go via get or the post. It doesn't matter. Either way around it can work. In case of mutation, they will always have to go via post. So it's on that side, again, like I said, it's more or less similar like traditional REST API. There is no big differences. Any other questions? If not, thank you very much.